is perpendicular, right? The surface is flat on. Yes or no? Right? It's perpendicular and that. So what it means is x, okay? The x surface over here is your what? Fracture surface orientation. So the fracture surface orientation is vertical. Yes or no? Right, that's your fracture. So that is the easy part. Next, we are going to do positive. Repeat again. The next thing we are going to do is we are going to deal with unidirectional torsion. Okay. So what is going to happen now is we have our chalk. Bear with me, okay? Bear with me. So same thing. Orientation, this is X. This is Y. And this is Z. Okay. The far end is your RH. RH means your right hand. Be clear. The close end is known as our LH. LH means our left hand. So what I want you to do with your right hand and your left hand is your right hand will twist towards the board. The left hand will go away from the board. Okay, don't do anything yet. Don't do anything yet. Bear with me. Okay. Likewise, we are going to draw an element. Okay. So now, by looking at the element, if I zoom in, we know that the shear stress over here is going up. This is coming down. And this is how the shear stress pattern will look like. Okay. So what it means, don't do anything yet. Patient, okay? My daughter always tell me that patient. What we see now is we are going to induce what we call a what? Positive shear. Okay. So now the thing is this. We are going into Mohr circle now. Okay. Likewise, before we construct Mohr circle, we label this as our surface X. We label this as our surface Y. Okay. So now we are going to construct Mohr circle. Okay. So this is our normal stress. Shearing stress, rotating clockwise. Shearing stress, rotating anti-clockwise. Can you all do me a favor? On your own account, label where is point X and where is point Y, just under what? Shearing stress. And the fact that we know that stress X and stress Y are on this line. Okay. And then I'm going to sketch this. This is our shearing line. Okay. So which one is your point X? At point X, the element will rotate clockwise or anti-clockwise. So if you look at point X, the element based on this arrow will rotate what direction? Counterclockwise. So counterclockwise over here, this is your point X. Okay. And on Y, based on the shear down here, is going to rotate what direction? It's going to rotate in a clockwise manner. Okay. So this is now your Y. Okay. So now we are going to sketch our diagonal circle. Okay. Now, from what we learned over here, this is known as our fracture what? Surface orientation. Right? So now we know that this is our element, this is our surface X, and this is our element, this is our surface what? Y. Okay. So now the element will rotate. Okay. So the fracture direction now, if we bring back to the fracture surface, is going to be what? It's going to rotate by 45 degrees anti-clockwise. It's going to rotate itself by 45 degrees. So now, when you see here now, we are going to anticipate 45 degrees from X. So we are very sure, not very sure, we are going to say that the fracture plane will occur in this direction. Pardon me, okay? The fracture plane will now occur in this direction. And from X, it's going to rotate anti-clockwise by what? 45 degrees. Now, you can use this surface over here. You can call this X also. It's going to rotate in the same anti-clockwise by 45 degrees. Okay. So you constructed Mohr circle. Are you comfortable with Mohr circle now? Yes or no? So the first time I show you guys what? Now you understand the fundamental. Now you see the physical. We're clear. Okay. So from here, again, we take our chalk. Okay. Be patient. Okay. Draw exactly the same thing over there. Okay. So I'm going to draw exactly the same. Don't break your chalk yet. Don't break your chalk yet. Okay. So now we know label your X. Okay. And then label your what? Your Y. Okay. Are we good? So on your right hand, okay, so this is your right, put R. Okay. On your right hand, you will be twisting in this direction. Okay. That's your right. Okay. On the left, you'll be pulling in the opposite direction. Right. Are we good? Now, let me ask you a question. In real life, when will a shaft fail? Now, I'm introducing the later part of the course where you have to do failure and listen to me. When will the chalk fail? Will the chalk fail when it's rotating? When all of a sudden, this is 2Q now. When all of a sudden you decide to what? Stop. Because when you are under constant velocity, you have no what? Acceleration. when you have a certain velocity coming down to 0, you have a sort of acceleration which is what? Negative. Or if your right hand wants to turn forward, your left hand wants to turn towards you. Then you're traction. When it's rotating, the failure mechanism is very different. It's opposite, which you will learn in P03. Be clear? Okay. So failure will only occur when you decide to stop or change what? Direction. That is why, how many of you drive? Go onto the motorway and engage reverse and see what happens. You see why it's not recommended? No. Yes or no? All of a sudden, it's rotating in one direction, and then you ask it to go in the what? Reverse. Okay, try it. Okay. I will call CAA. And we will video it. So now, don't do anything. Okay, don't do anything. I will do it first, okay? So the right, I go this direction, the left, I bring it back. Now, don't induce any bending, yeah? I did not teach that yet, but we are going there. So now when I twist, okay, and you can see, right? If I were to sketch, this is vertical, yes or no? Right? It will rotate in a what? Anti-clockwise direction by what? 45 degrees. Are we clear? So anti-clockwise. So exactly, okay, as you can see, or if I were to use this surface over here, right? If this is our X, it will orientate itself anti-clockwise by what? 45 degrees. We clear? Okay. Now, it's your time now. I'm getting too old. You break your chalk in terms of what? In terms of here. So on your right hand, twist towards the board. On your left hand, twist towards you. Twist, rotate, don't bend. Okay. Once you have that, okay. Are we okay? So once, listen. Right? So once you have that, right, I want you to exchange chalk with someone on your left or someone on your right. Just change one piece of chalk. And you will realize the fracture is the same orientation. Or no? No. Oh, man. No, you can't really twist it. You all get the same orientation, yes or no? Yes, no, friend. Right? Okay? You get it? Got it? Right? So you see it. So now, you can predict the correct direction of it there. Okay, so when you go for your job interview, if someone were to ask you, what do you know about solid mechanics? Now, the question is, right? Now you're, am I, okay, I don't want to flatter myself, okay, but you understand why now, yes, no. You can relate based on what? Whole circle. Right? It's not like, yes or no? You can see something. Now, the question is, next time anyone interview you, you ask them, why it did not rotate in this direction? Yeah. Yeah. Stop. Oh, by the way, I've got security with that. And there you go. The next time. I broke, I keep my, okay. here we have an investigation going on. I know. And they say they're good to go, and they say don't draw anymore. Then I give them a list of. You're like, if I told them I'm really complaining. But anyway, right. So we know it will not go to the other orientation because over here it's under what? Compression. Are we clear? Right? So I've repeated this before. So if those of you have such test, change with your friend, can see now. The next one, okay, it's up to you whether you want to do it or not to seal your understanding. Is we are now going to do what? The test that we are going to do is under negative shear configuration. Okay. So in negative shear, if someone asks you to induce, so I'm not going to draw so much. Okay. I'm going to draw negative shear for you. So negative shear for us is now looking like this. Right? This is known as our negative shear. So this is our X, and then this is our Y. So now we are going to sketch the element. Okay. This is my normal stress. This is shearing stress. Element rotate clockwise. Element rotate anti-clockwise. And I'm going to draw our shear line. Okay. So now X is going to be at the top because the element is going to rotate this way. And Y is going to be at the bottom because the element is going anti-clockwise. So now we draw our Mohr circle. Okay. And here is again our fracture surface orientation. So now our crack now, right, from point X, so I want you to draw your surface X down here, and I want you to draw your surface Y down here. Okay. So now X, now it will come here, it will rotate in a what? In a clockwise direction. Okay. So now we will rotate in a clockwise direction. Okay, clockwise direction. So the element rotate in a clockwise direction. And then what will happen is this is our X, and then this is our fracture orientation. Oh no, is that? I think I got something mixed up. No, that's not our fracture surface, sorry. So we rotate this as our X, right? And then this is our fracture surface. Okay. So now our fracture surface now will go this way. Okay. i.e. from X is going to rotate in a in a clockwise manner by 45 degrees. Okay. So how do we do that? Because I'll let you guys copy. I'm again going too fast. You need to calm down. Now, okay, I want you all to do negative shear.